So far, when we've discussed vector algebra, we've learned how to do it graphically. And when I say vector algebra, I mean adding vectors, subtracting vectors, multiplying them by scalars. So we saw how, for instance, if we add vectors, we just draw them down, put them tail to tip, and then can compute the resultant vector. In this video, we've now seen how we can quantify vectors. And in particular, we've seen how to quantify them using their x, y, and potentially z components. Although often we don't think about the z one because I can't draw a vector coming out of the board. So usually we stick to 2D. So we only have an x component and a y component. In this video, we're going to see how we can do vector algebra, which again is adding vectors, subtracting vectors, and multiplying them by a scalar if we are given the components of a vector. So let's say we have these two vectors, a and b, where again, ax and a sub y are the components of vector a, b sub x and b sub y are the components of vector b. If we want to add two vectors, then this is the formula that we use. For the new vector, right, and we know it's still a vector, it still has these x hat and y hat unit vectors, we simply add the x components together for the new x component and the y components together. And if you can't see how I got to this, we can actually sort of derive it with one sort of line. Right, a plus b. If I literally just copy down my expressions for a and b, I have ax, x hat, plus ay, y hat, plus bx, x hat, plus by, y hat. Sorry, my sub y's look a little bigger than they should be. And then all I've done to get from here to the next line is I have collected the x terms, right? These are the two x terms, and then I just factored them out. And so here's the x hat, and I just factored the two x components out. And then I did the same thing with the y terms. I just grouped them over here and factored the y hat out. All right, so ultimately, this is the formula that you need for adding vectors given components. If we had a z component, then we would just have another term here with a sub z plus b sub z, z hat. All right, now the same thing sort of happens. Let me just erase all of that because it's sloppy. The same thing happens if we want to subtract vectors. Now all we do, and we could write it out and combine terms in the same way, but ultimately, this is the formula that you'll use for subtracting vectors. All you do is subtract the x components for the new x term and subtract the y components. And then finally, if we're multiplying a single vector by a scalar, that scalar just multiplies each of the components individually. And again, we can see that by literally c times a is c times ax x hat plus ay y hat. And now all I've done is I've factored this c, which c is representing a scalar. All I've done is I've factored that in, and that's how we get to this formula right here. All right, so that's how you do vector algebra given components of vectors. Now, to really solidify this, let's do a couple quick examples. So given the following vectors, what is the result of a plus b? And you'll already notice here, instead of x hat, y hat, and z hat, we have I hat, j hat, and k hat, but it means exactly the same thing. So what I'd like you to do is to pause the video here and try to do this on your own before we do it together. All right, so what's the answer? The answer is B. And how did we get to that? Let's just do it quickly together. A plus B is equal to, and I'm just going to copy this whole thing down. right? Where this first part is just A, and then I've added B, right? And now what I want to do is I collect the I hat terms. So this is 3, and then minus I hat is really minus 1 times I hat, right? And then plus the J hat term, so minus 4, and then you'll notice there isn't a J hat term for B, and so really that's like 0 times J hat, and then plus 1 plus 5, right? Where again, we can think of this as AX plus BX, AY plus BY, and AZ plus BZ. All right, and then this is equal to 2I hat minus 4J hat plus 6K hat, which is indeed the answer B here. If you got one of the other ones, probably what you did is you messed up a minus sign or something like that. So make sure to be careful and include your minus signs where appropriate. All right, so let's do one more. So what if instead we wanted to subtract the vectors? So again, what I'd like you to do is to pause the video here and try to do it on your own first. Okay, so we could expand out rewriting both these vectors again, or we could use the sort of simplified formula that is A minus B is equal to AX minus BX I hat plus AY minus BY J hat plus AZ minus BZ K hat, where again, 3 is AX, minus 4 is AY, and then AZ is 1, right, which is implied right here. Minus 1, this is really a minus 1, is BX, BY is 0, and then BZ is 5. And now we just plug all of these numbers in. So we get 3 minus 1, which is going to ultimately be plus 1, I hat, plus minus 4, and then minus 0, J hat, plus, and then in our final term, we have A sub Z is 1 minus 5, K hat. So this is 4 I hat minus 4 J hat minus 4 K hat. So it's, oh, I guess I didn't give you the answer yet, so that must be C is the right answer. So again, if you got one of the other answers, you might have simply made a mistake, not carrying a minus sign or something. So you have to be careful with things like this, where we have minus -1, so that ends up being +1. So indeed, C is the correct answer here. So that's how you can add and subtract vectors using their components.